Hello everyone, this is Sir Marvin. So today for statics of rigid bodies, we're going to discuss the second lesson, which is the resultant of concurrent force system. So for this topic, the learning outcomes would be students must be able to compute the resultant of concurrent force systems. And the second one is to locate and draw the resultant of concurrent force system. So previously, we have discussed how to solve the resultant of two concurrent forces, right? So we solved that using triangle law. So now, what if your forces, your concurrent force system now has three or more forces? Okay, so can we still apply triangle law for that? Okay, so in solving the resultant of three or more concurrent forces, we can actually use two solutions, okay, or two approaches. So the first method of solving resultant of three or more concurrent forces is what you call graphical method. So actually, your triangle law, okay, the triangle law that we have discussed, that is actually a graphical method. So graphical method, what you do here, the two vectors can be added to give a resultant. This resultant, in turn, can be added to a third vector, etc., until all the vectors have been added together to give an overall resultant. These vectors can be added in any order. This method is sometimes called the head-to-tail method or the tip-to-tail method. So, again, the triangle law that we have discussed, that is a graphical method. But that will just be a triangle if the forces, okay, that are in the system, okay, or in the force system are two forces. But what if the forces are three? So if we apply um, the head to tail method or this graphical method, if you're going to draw, okay, three forces, it will be like this, right? So these are the three forces that are drawn from tip to tail passion. Okay, and the last side of this drone forces will be this side, and that side will be the resultant. Okay, so that's how you uh, draw, okay, graphically, okay, the forces, okay, that are in a force system, or three forces, three or more forces in a concurrent force system. So the polygon form here in this case is not a triangle, since these are three forces, right? So the polygon formed here is a quadrilateral. Now, there are also laws for quadrilaterals, but the thing is, it will be harder, okay, or more difficult than your triangle. Okay, so we're not going to solve, okay, resultant of three or more concurrent forces using graphical method. Okay, we're not going to use this method. So the method that we're going to use is the next one. Okay, so let's talk about that. Okay, so this is the second method, and the method that we're going to use, okay, to solve for resultant of three or more concurrent forces. So this is called analytical method or component method. Okay, so for this method, the vectors or forces can be resolved into components that coincide with arbitrarily chosen axes. So the chosen axes that we're talking about here are the x and y axes. Okay, so what we're going to do here is that we have to resolve our forces into components. So the components that we're talking about here are the horizontal and vertical components. So previously, the component that we talked about are the forces, okay, are the forces that make up the resultant. Okay, but here the components that we're talking about again is the x component or horizontal component and the y component or vertical component of the force. So what we're going to do here, so let's consider first, let's say this is a force, this in blue color. Okay, so let's say this is a force. Okay, so this force has horizontal and vertical component. Okay, so its horizontal component will be this force. Okay, so if the direction of this component depends also on the direction of the resultant. So if your resultant is directed to the right, so obviously your horizontal component should be directed also to the right. Okay, so this will be the horizontal component of this force. And also, if you want to solve for the vertical component of this force, okay, so this will be the vertical component of this force. And if the direction of your resultant is directed upward, so obviously your vertical component should also be directed upward. So these forces are the component forces of this result or of this force. Okay, so these two forces is equivalent also to this force. Okay, so what we're going to do here in component method is that we're going to sum up, okay, all the vertical components of forces and all the horizontal component of the forces in the system. So this will be our formula. This will be R is equal to square root of Rx squared plus Ry squared. So R will be your resultant. Okay, that will be the magnitude of your resultant. And this is given by this formula. Where in your Rx, okay, that will be the horizontal component, okay, of your resultant. And your Ry will be the vertical component of your resultant. Now, for the horizontal component of your resultant, that will be Rx, it will be solved, okay, by summing up all the horizontal component of all the forces in the system. Meanwhile, your Ry can be solved by summing up all the vertical components, okay, of the forces in the system. Okay, so it is important here, class, that you know how to solve vertical and horizontal components of forces. So we're going to talk about that on the succeeding slides. Okay, and also for summation, okay, so dito muna. So the parts of the answer, no, if you are asked to give the resultant, you should give the magnitude. This will be the magnitude, and you should also give the direction, okay, and also you have to give the angle, okay, or the theta x, okay, of the resultant with respect to the x-axis or with respect from the horizontal. So your theta x can be solved using tangent of theta x equals to ry over rx. So this is just TOA, right? So from here, as you can see here, so there can be a formed triangle here. So this will be the formed triangle. So this side is also ry. So this side of the triangle will be ry. This will be rx. And the theta here that we're looking to is the theta x. So this will be the theta x. And then using tangent theta or TOA, so that will be opposite over adjacent, and the opposite side will be ry, and your adjacent side will be your rx. So that will be tangent theta x equal to ry over rx. So that will be the theta x. That's how you solve theta x. And also, for your summation for your rx and ry, okay, we have to use the following sign convention. Okay, so for forces, okay, that are horizontal, that are directed to the right, okay, so its sign is positive. But if it is directed to the left, that will be negative. This is the sign convention for your summations, ha? Okay, and also, if your force is directed or your component force is directed upward, okay, so it is positive. Okay, its vertical component is positive, but it is directed downward. Okay, so its vertical component will be negative. Okay, so that this will be the sign convention for the summation of vertical and horizontal components of forces. Okay, so let's try to solve problems. Okay, so before we proceed to solving resultants of three or more concurrent forces using component method, let's first recall how to solve the components of forces. Okay, so we have here the following examples. We have to find, okay, the horizontal and vertical components of forces. So the first example, so this is force P. So this is force P and this is 30 Newton and this is 40 degrees from the horizontal. So we have to solve for the horizontal and vertical component of this force. So in this case, the horizontal component of this force will be Px. Okay, and the vertical component will be Py. So it will be directed the same direction as your resultant, ha? So since your resultant is directed to the right, so your horizontal component should be directed to the right as well. And also, since the resultant is directed upward, okay, so your vertical component should be directed upward. So this will be the vertical and horizontal components. Now, in order to solve the horizontal and vertical component, Okay, so there will be a triangle formed here. So this will be the triangle form, and this triangle has 40 degrees theta here. Okay, and we have here 30 Newton. This side is P, which is 30 Newton, and this side will be the vertical component of the force, right? This is also equal this P. If this is Py, this is also Py. Okay, so and this is px. Okay, so your px will be the adjacent side of your triangle since your angle is here. Okay, so again, if your angle is here, your adjacent side will be your px, and your opposite side, okay, will be the vertical component of the force, which is py. Okay, so from this triangle, we can actually solve for px and py. So since this is a right triangle, we can use SOHCAHTOA. Okay, so from SOHCAHTOA, let's say cosine theta. So your theta is 40 degrees. Okay, so cosine 40 degrees, that will be CAH. CAH. Okay, so your adjacent side over hypotenuse. So in this triangle, your adjacent side is PX. So that will be PX over your hypotenuse, which is P. Okay, so this will be your hypotenuse. So that will be P. Okay, so that will be the equation for cosine 40 degrees. Now for sine, sine is so. That will be opposite over hypotenuse. So your opposite side of the triangle will be PY and your hypotenuse will be P. So that will be sine 40 degree. Sine 40 degrees equal to PY over P. So from here, we are solving for PX and PY. So we can solve for PX and PY. So for PX, we just cross multiply this. So this will just be P times cosine 40 degrees, wherein your P is 30 Newton. So that will just be 30 cosine 40 degrees. And inputting that in your calculator, that will be 30 cosine 40, and that will give you 22.98 Newton. Okay, so this will now be the horizontal component of your force P. Okay, that will be 22.98 Newton. Now, for the vertical component, that will be Py. So your Py, you just cross multiply this. So that this will be P sine 40, wherein P is 30 Newton. So 30 times sine 40. Okay, so inputting that in your calculator, that will give you 19.28 Newton. So this will now be the vertical and horizontal component of your force P. So this is what we are looking for this problem. Okay, so let's try solving the next example. So this is example number 2. Okay, so we have here force Q. So force Q is 20 kilonewton, and the angle here is 50 degrees from the vertical. Okay, so our angle here is here. Okay, so what we're going to do here, we have to solve for the horizontal component, which is QX, and the vertical component of Q, which is QY. Okay, so we have to create a triangle to solve this. Okay, so this will be the triangle that will be created. So our angle is here, 50 degrees. So the triangle should be this triangle. Okay, since your angle is here. Okay, so since your angle is here, okay, so your adjacent side will be your QY, right? Your adjacent side will be your QY, and your opposite side will be your QX, right? So this will now be the triangle, and from that, we can solve for QX and QY. So solving for QX, or let's first use SOHCAHTOA. Okay, so let's use cosine theta, wherein your theta is 50 degrees, and this is CAH. So CAH, so adjacent over hypotenuse. So in this case, your adjacent side will be your QY. So your QY is this. So this will be QY over Q. Okay, wherein your Q is your hypotenuse side, right, which is 20 kilonewton. Okay, and also for sine 50 degrees, so that will be so opposite. The opposite side for this triangle is QX over hypotenuse, which is Q. Now solving for QY and QX. So for QX, that will be, we will just cross multiply this. This will be Q sine 50 degrees, wherein Q is 20 kilonewton. So this will be 20 times sine 50. So solving that, inputting that in your calculator, that will give you 15.32, and the unit is kilonewton. Don't forget the unit, class. Okay, so this will be the horizontal component uh, your of your force Q. Now for the vertical component, so this is the vertical component, okay? So this will now be cross multiplied. So this will be Q times cosine 50. Okay, wherein your Q is 20 kilonewton. So that will be 20 cosine 50 degrees. And that will give you, if you input that to calculator, 20 cosine 50, that will be 12.86 kilonewton. So this will now be the answers for this. These are the horizontal and vertical components of force Q. So for the third example, so the given force here is T is equal to 35 pound. And as you can see here, there's no angle given here, right? So instead, the given is a slope triangle. So the slope triangle is this triangle, no? And so here, okay, if we're going to solve for the horizontal component of force T, so it will be Tx, okay? And if we're going to solve for the vertical component, that will be Ty. So to solve for the horizontal component and vertical component, we need theta here. So the theta here will just be equal to the theta of this slope triangle. Okay, and also to solve for, let's say, for the horizontal component of t, which is tx, that will just be equal to t cosine theta, right? If there's a theta here, but since there's no theta here, okay, we will consider the theta for the slope triangle. So taking up this slope triangle, so this will be the slope triangle. Okay, so the rise is 3. Okay, and the run is 4. Okay, so this theta will also be equal to this theta. So this will be the theta for the slope triangle. So meaning to say your 3 will be your opposite side or the opposite side of this triangle, and 4 will be the adjacent side, right? So we have to solve for the third side of this triangle. We have to solve for the hypotenuse. So since this is a right triangle, we can use Pythagorean theorem to solve for the third side or for the hypotenuse. Okay, so that will be c squared is equal to a squared plus b squared, wherein c is the hypotenuse of the triangle and a and b are the sides other than the hypotenuse, no? So substituting 3 and 4 to a and b, so this will be c squared is equal to 3 squared plus 4 squared. So solving for c, that will give you 5. So this will be the hypotenuse of this slope triangle. Now since we need theta, no, to solve for the, let's say, for the horizontal component, the formula here is for tx will be t cosine theta. So we need cosine theta. So from the slope triangle, we can actually get cosine theta. So cosine theta will be equal to k adjacent, which is 4 over hypotenuse. So that will be 4 over 5. So instead of solving for the angle of the triangle, okay, we can directly use 4 over 5 as the equivalent of cosine theta. Since tx equal to t cosine theta, okay, so we substitute t as 35, okay, and cosine theta, we substitute that as 4 over 5. So that will be the equivalent of cosine theta. Okay, so solving 35 times 4 over 5, so inputting that in your calculator, so that will be 28. So your horizontal component will be 28 pound. Now, for your ty or your vertical component, so what we need here is sine theta, right? So to solve for ty, if theta is here. Okay, so we need sine theta. So from the slope triangle, we can solve for sine theta. Sine theta is so opposite over hypotenuse. So the opposite side here is 3 and the hypotenuse is 5. So that will be 3 over 5. So solving for ty or vertical component of t, so that will be t sub y is equal to t sine theta, wherein your t is 35 and your sine theta is 3 over 5. So that will be equal to, if you input that to your calculator, that will be 35 times 3 over 5. That will be 21 pound. Okay, so this will now be the horizontal and vertical component of force T. Now, to put this simply, no, so we can actually solve this in a simpler way, no, the horizontal and vertical component of force T. So when you have a slope triangle, so if you have a slope triangle, what you really need to do is to solve first for the hypotenuse. Okay, after solving for the hypotenuse, if you are solving for tx, so that will just be equal to t times the adjacent, the side, okay, that is parallel to the to the component that you are looking for. Since you are looking for tx, so the side that is parallel, okay, in the to that side, okay, in the slope triangle will be this side. So that will just be 4 over the hypotenuse, which is 5. So this will be the result. That will be 35 times 4 over 5. Now, if you are looking for the vertical component, so that will be ty. So what you're going to do here is just multiply t, which is 35, to the side that is parallel to the component that you are looking for. So the component that you're looking for is vertical component, and the side in the slope triangle that is parallel to that is 3. So that will be 35 times 3 over the hypotenuse. So it's more simple, no, if you solve it that way. Okay, so that is for slope triangle, solving for the horizontal and vertical component using slope triangle. Now, let's proceed to example number 4. So as you can see here in example number 4, the force here is force M, which is equal to 17 kips. Okay, so this force is actually vertical. So if we're going to solve for the horizontal component, no, so there's actually no horizontal component for this because this is a vertical force. So obviously, its horizontal component will be 0, and its vertical component my, of course, obviously, that will be 17 kips. It will be the same because this is already a vertical force. Now, for number 5, okay, so this is force B, which is equal to 96 Newton. Okay, so this is actually a horizontal force. Okay, so its horizontal component will just be the same as the force because it is already horizontal. So that will just be 96 Newton. And the vertical component obviously will be 0 since this is a horizontal force. Okay, so that will be the answer. Now, for example number 6, okay, so we are asked here to find the horizontal and vertical components of force F, wherein force F is 12 pound. And the given here is the dimensions of the triangle formed, right? So the given here are these dimensions. This is 3.1 centimeter and this is 3.7 centimeter. So if this is the given, it's more simple if you solve this, okay, by solving first the theta. So you can solve the theta from this triangle, okay, since the given are this is the opposite side since theta is here. So this will be the opposite side of the triangle and this is the adjacent side. So the given are opposite and adjacent side. So what trigonometric function has opposite and adjacent? TOA. So that will be tangent. So to solve for theta, you can use tangent theta, which is equal to TOA opposite over adjacent. Your opposite side will be 3.1 and your adjacent side will be 3.7. So solving for theta, that will just be arctangent of 3.1 over 3.7. So inputting that in your calculator, that will be arctangent of 3.1 over 3.7. That will be equal to 39.96 degrees. So this will now be the theta. So after solving the theta, we can now solve for the horizontal component of F and the vertical component. So for the horizontal component, that will just be F times cosine theta. So your cosine theta or your theta will be 39.96 degrees. So your F will be 12. So solving that, inputting that in your calculator, that will be cosine 12 cosine 39.96. So that will give you 9.20 pounds. So that will be the horizontal component. Now for the vertical component, it will just be F times sine theta, wherein your F is 12 and your theta is 39.96 degrees. So solving that, inputting that in your calculator, that will be 12 sine 39.96 degree, and it will give you 7.71 pound. So this will now be the answers for this problem. So now, since we have already recalled the on how to solve the components of forces, we can now proceed to solving a concurrent force system with 3 or more forces, okay, using component method. Okay, so let us consider the first sample problem. So the question here is, determine completely the resultant of the concurrent force system as shown. So the concurrent force system shown, okay, here, okay, is composed of 1, 2, 3, 4, 5 forces. So we cannot use triangle law for this because this is already three or more forces. Okay, three or more concurrent forces. So we're going to solve this using component method. So we have here 200 Newton force that is 30 degrees from the horizontal. We have here 300 Newton here, and it is 60 degrees from the horizontal. We have here horizontal force, which is 400 Newton. We have here vertical force, which is 50 Newton. And we have here 100 Newton force, which is 45 degrees from the horizontal. Now, we are asked here to solve for its resultant. So let's solve this. Okay, so the first thing that you have to do is to list down the things that are being asked, okay, in the question. So in the question, we need to find the resultant, and also to solve for the resultant, okay, you have to give the magnitude, okay, the direction, and the angle, okay, of the resultant from the horizontal axis or the theta x. Okay, so again, this is the given concurrent force system. So to solve this, okay, to solve for the magnitude of the resultant, the formula will be R is equal to square root of Rx squared plus Ry squared, right? Wherein your Rx will be the horizontal component of your resultant, while your Ry will be the vertical component of your resultant. So we have to solve first for Rx and Ry. So for your solution, let's first solve for the Rx. Again, Rx is the horizontal component of the resultant. So to solve for Rx, that is just equal to summation Fx, wherein summation Fx is the summation of all the horizontal components of the forces in the system. So, in short, okay, we need to solve, okay, for the horizontal components of every force here in this force system. Okay, and we're going to consider the sign conventions that we have talked about, okay, in the introduction of this topic. Okay, so if the force, okay, is directed to the right, so the horizontal component for that will be positive. Okay, but if it is directed to the left, so your sign for that, okay, for your component, horizontal component will be negative. And if it is directed upward, that will be positive. And if it's directed downward, that will be negative. Now, let's start summing up all the horizontal components of this force system. So that will be Rx equal to all the components or horizontal components of all the forces. So let's start with 200 Newton. So what is the horizontal component of 200 Newton? So that will be 200 cosine 30 degrees, right? And since this is directed to the right, so this will be positive. That's why it is positive 200 cosine 30 degrees. So the next one is the 300 Newton force. So we have to solve for the horizontal component of 300 Newton force. So its horizontal component will be 300 times cosine 60, right? So since this is the angle, so that will be cosine 300 cosine 60 degrees, right? And since this is directed to the left, so the sign convention for this will be negative. That's why it is negative 300 cosine 60 degrees here. Okay, and also the next force is this 400 Newton force. So since this is already horizontal, this is already the horizontal component already. So this is 400 Newton. But since this is directed to the left, okay, so this will be negative. That's why this is negative 400 here. Okay, now for your 50 Newton force, there's no horizontal component for your 50 Newton force because it is vertical. So you can skip that. Okay, so lastly, for your 100 Newton force, so solving for the horizontal component of 100 Newton, so that will just be 100 cosine 45 degrees, right? And since it is directed to the right, okay, so it will be positive. That's why it is positive 100 times cosine 45 degrees here. So now, solving for this, okay, solving for your Rx, so inputting this in your calculator, this will be 200 cosine 30 minus 300 cosine 60 minus 400 plus 100 cosine 45. So the answer will be negative 306.08. So don't forget the sign, which is Newton. So the negative sign okay, for Rx indicates the direction, okay, of the horizontal component of your resultant. If it is negative, okay, the assumed positive direction for horizontal components is to the right. The force should be directed to the right for it to be positive. So since negative, the answer is negative. So meaning to say that your horizontal component is directed to the left, right? So you can say that your Rx is 306.08 Newton directed to the left. So that's how you can know the direction of your component that you have solved. Okay, now this is now the value for Rx. Now let's solve for Ry. So we also need Ry. So Ry will be equal to summation of Fy. So this will be the summation of all the vertical components, okay, of all the forces in the system. So again, we're going to follow the sign convention that if the force is upward, okay, the sign convention for that is positive. But if the force is directed downward, so the sign will be negative. So let's start to solve this. So this will be Ry is equal to, the first force is 200 Newton. So let's solve for the vertical component of 200 Newton force. So that will be 200 sine 30. Okay, and since this is directed upward, so this will be positive. That's why it's positive 200 sine 30 degrees here. Okay, and also for the next force, that will be 300 Newton. So that will be, the vertical component here will be 300 sine 60 degrees. Okay, so since this is directed upward, so this will be 300 positive 300 sine 60 degrees. Okay, the next force will be 400 Newton, but since 400 Newton is a horizontal force, so it will not be included in the summation of vertical component of forces. So the next force is 50 Newton. So since this is already a vertical force, so you just add that directly here in your summations. But since this is directed downward, so this will be negative. That's why it's negative 50 here. So your last force will be 100 Newton. So for your 100 Newton, the vertical component for this is 100 sine 45 degrees. But since this is directed downward, so it will be negative here. That's why it's negative 100 sine 45 degrees here. So solving for Ry, so let's input this in your calculator. So this will be 200 sine 30 plus 300 sine 60 degrees minus 50 minus 100 sine 45. So this will be 239.10 Newton. And the answer, okay, is positive. So meaning to say, since the assumed positive, okay, direction for Ry is upward, it means to say that your Ry is upward. Okay, so that's the direction of the vertical component of your resultant. Okay, so it is directed upward. Now, to solve for the magnitude of the resultant, so that will just be square root of Rx squared plus Ry squared. So that will be equal to R is equal to square root of your horizontal component, which is negative 306.08 Newton, plus 239.10, which is your Ry, okay, squared. And the resulting R will be equal to, if we input that to calculator, that will be 306.08 squared plus 239.10 squared. So that will be 388.40 Newton. So now that will be the magnitude of the resultant. Now for the direction of the resultant, okay, it will depend on your components, in the direction of your components. So the direction of your Rx is to the left, and the direction of your Ry is upward. So the direction of your resultant will be upward to the left, right? So this, it will be drawn this way, upward to the left. So this will be the magnitude and the direction of the resultant. Now, we still need to solve for the theta x. So for theta x, that is just, okay. So let's first draw the resultant, no? So if we're going to draw the resultant, this will be the orientation of the resultant. Okay, it will be here. Okay, it will be in this quadrant. Okay, since this is upward to the left, so this will be directed this way. And the magnitude of this resultant R is 388.40. Now for theta x, okay, so this will be your theta x. So to solve for your theta x, since we have the vertical component and the horizontal component already of your resultant R. So we can solve that using tangent. So TOA lang yun. So that will just be TOA. Diba? Tangent is equal to opposite over adjacent. That will just be tangent of theta x, opposite over adjacent. Your opposite side will be the ry, okay, will be the vertical component of your resultant, and your rx will be the horizontal component of your resultant. So that will just be arctangent. To solve for theta x, that will just be arctangent of ry over rx. So that will be arctangent of 239, your ry, 239.10 over your x, which is negative 306.08. Okay, so that will be equal to 37, or it will be now negative 38 degrees. Okay, so that will now be your theta x. So the negative sign here indicates that your angle, okay, from the x-axis, from this x-axis, is rotated in a counterclockwise direction. So that's the negative sign represent, no, that from this x-axis, okay, to your resultant, it is counterclockwise, right? So since it is measured in a counterclockwise manner, so that will really be negative. But if it's measured from here, let's say here, so that will be positive. Okay, so let's say your angle, your resultant is in the quadrant 1, so your angle will be positive. But anyway, your that sign is not really important naman, since we have here the direction. Okay, so now, this will now be the answer. So this will be the magnitude of the resultant, this will be the direction, and this will be the angle. So these are now the answers for this problem. Now, for sample problem number 2, we have to compute the value of the resultant of the concurrent forces shown. Okay, so again, we have here 1, 2, 3, 4, 4 concurrent forces. So we really have to solve this using component method. So let's solve this. So again, you have to write first what is being asked in the problem. So what is being asked in the problem is the resultant. Again, we have to solve for the magnitude, for the direction, and for the theta x. Okay, so again, this is the given. So we have to solve for the magnitude of the resultant, which is given by the formula r is equal to square root of rx squared plus ry squared. So we have to solve first for rx and ry. So to solve for rx, okay, so to solve for Rx, we just have to sum up, okay, to take summation of all the horizontal components of all the forces here. Okay, so let's solve this. So this will be Rx equal to, the first force is 100 Newton. So for 100 Newton force, the given here is a slope triangle. So in this slope triangle, since what we need is a horizontal component, so the horizontal side, okay, of the slope triangle is 2. So we just have to multiply 100, okay, this 100 Newton to 2, which is the parallel side, okay, of the component that we are looking for, which is the horizontal side. So we multiply 100 to 2 over the hypotenuse of this slope triangle. So solving for the hypotenuse of this slope triangle, that will just be square root of 1 squared plus 2 squared, which will give you square root of 5. So the hypotenuse of this slope triangle will just be square root of 5. So the horizontal component of 100 Newton will just be equal to 100 times 2 over square root of 5. Since this is directed to the right, so this will be positive. Now for your 300 Newton force, okay, so we need to solve for the horizontal component, and the horizontal component for this will just be 300 times cosine 60 degrees, since your angle is here. So that will be 300 cosine 60 degrees. And since this is directed to the left, so this will be negative here. And also for your third force, this will be 200 Newton. Okay, so to solve for its horizontal component, that will be 200 cosine 45 degrees. Okay, so we have here 200 cosine 45 degrees. And since this is directed to the left, that will be negative here. Okay, so that will be 200 cosine 45 degrees. And for the last force, so this will be the last force. This is 400 Newton. And its horizontal component will be 400 cosine 30 degrees. And since this is directed to the right, so this will be positive. That's why it's positive 400 cosine 30 degrees here. Okay, so solving for this, okay, so solving for Rx, let's input this on your calculator. So this will be 100 times 2 over square root of 5 minus 300 cosine 60 degrees minus 200 cosine 45 degrees plus 400 cosine 30 degrees. So it will give you 144.43 Newton. Since the answer is positive, meaning to say that your Rx is directed to the right. Okay, since the answer is positive, so it will be directed to the right. Now, let's also solve for Ry. So your Ry will be the summation of all the vertical components of all the forces. So for your Ry, so your first force is 100 Newton. Okay, so the vertical component of this 100 Newton force using the slope triangle will just be 100 times the side that is parallel to the side that we are solving, which is the vertical. So we are solving for vertical components. So the side that is parallel to the slope triangle is this side, which is 1. So just multiply 100 to 1 over the hypotenuse, which is square root of 5. Now, since this is directed upward, this will be positive. That's why it's positive here. Now, for your 300 Newton force, the vertical component will be 300 sine 60 degrees, and it is positive since directed upward. And for your third force, that will be 200 Newton. So to solve for its vertical component, that will be 200 sine 45 degrees. And since it is directed downward, that will be negative. That's why it's negative here. And lastly, for your 400 Newton force, since the vertical component for this is 400 sine 30, and since this is directed downward, so this will be negative here. So solving this and inputting this on your calculator, so that will be 100 times 1 over square root of 5 plus 300 sine 60 minus 200 sine 45 minus 400 sine 30 degrees. So it will give you negative 36.89 Newton. Okay, so the negative sign here indicates that your Ry is directed downward. Okay, so your Ry will be 36.89 downward. Okay, so this will now be the Rx and Ry. We can now solve for the magnitude of the resultant. So for the magnitude of your resultant, that will just be equal to the square root of Rx squared plus Ry squared. So that will be square root of Rx, which is 144.43 squared plus your Ry, which is negative 36.89. So that will be negative 36.89 squared. So solving this, so let's input this on your calculator. This will be 144.43 squared plus negative 36 quantity, negative 36.89 squared. So that will give you 149.07 Newton. So that will be the magnitude of your resultant. And for the direction of your resultant, that will depend on the direction of your components. So your horizontal component is directed to the right, and your vertical component is directed downward. So that will be downward to the right. So your direction will be downward to the right. Now, for your theta x, we have to solve for that. Okay, so again, if you're going to draw our resultant, so the location of your resultant will be here since it is directed downward to the right. So this will be drawn here. So this will be your resultant, and your theta x will be this. Okay, so to solve for your theta x, so since we have the vertical component and horizontal component of R, we can use tangent. So TOA, opposite over adjacent. So using tangent of theta x, that will just be equal to Ry. So this is the opposite side of the triangle over Rx, which is the adjacent side of the triangle. So that will, to solve for theta x, that will just be arctangent of Ry over Rx. Wherein your Ry here, okay, your Ry is negative 36.89 over your Rx is 144.43. So let's input that in your calculator. Again, that is arctangent of negative 36.89 degrees over your Rx, which is 144.43. Newton pala yun, no? Newton rather. So the angle will be negative 14.32 degrees. So that will now be your theta x. So the negative sign here indicates that your theta x is measured, okay, in a counterclockwise direction. So we draw this theta x from the x-axis in a counterclockwise direction, right? That's why it's negative. But anyway, what's important here is the answer na yung magnitude natin is that our magnitude is r is equal to 149.07 Newton, and the direction is downward to the right, and the theta x is negative 14.32 degrees. So these are now the answers. Now, let's proceed to sample problem number 3. So for sample problem number 3, so I'll read the question. So the resultant of the concurrent forces shown is 300 Newton, pointing up along the y-axis. Compute the values of F and theta required to give its resultant. So for this third question, okay, so what the question is asking from us, okay, is not the resultant because the resultant is given. Okay, so the resultant is given. So the thing that is being asked here, okay, is F. Okay, your force F and this theta. So we have to solve this. Okay, so we're going to analyze this problem. Okay, and we're going to use a component method. Now, it is mentioned here that the resultant of the concurrent forces shown is 300 Newton, and it is pointing up along the y-axis. So it is pointing up along the y-axis. What does it mean? So if it's along the y-axis, it means that your resultant is a vertical force. So if it is a vertical force, it means to say that its horizontal component will be 0. And the vertical component, your Ry, will be equal to the resultant itself. Right? So your meaning to say your Ry will be 300 Newton and your Rx will be 0. Okay? So from that, no, we can now start solving. So let's solve this problem. So as I've mentioned, for our given, so the given is the resultant, okay, which is mentioned that the given is uh, 300 Newton and it points along, okay, the y-axis upward. So it meaning to say, okay, your resultant, okay, is a vertical force. Okay, so that vertical force resultant, its vertical component, syempre, will be 300 Newton as well. Okay, but your Rx, okay, for your horizontal component of your resultant, it will be 0 since it is a vertical force. So your Rx will be 0. Okay, and for the things that we have to solve for this, we have to solve for the value of F, this force F, and for this theta. Okay, so using our formula for solving Rx and Ry, we can use this given. We can use Ry and Rx. Now for Rx, let's say that Rx, it will be equal to the summation of all the horizontal component of all the forces. And we know that the value of Rx is 0. So we can say that this is 0 equal. So the first force is F. So the horizontal component of F is F cosine theta, and it is directed to the right. Therefore, this is positive. That's why it's positive F cosine theta here. Then for the next force, we have 500 Newton. And this 500 Newton force is already a horizontal force. Therefore, this is just 500. And since this is directed to the left, so it will be negative 500 here. Now, for the last force, so this will be the last force. So this is 240 Newton, and the horizontal component for this is 240 cosine 30 degrees. Since it is directed to the right, so it will be positive here. So this will be the first equation. So since we have two unknowns, F and theta, we have to generate two equations. So this will be the first equation. And the second equation will be derived from your Ry. So since we have a given Ry, we can use the formula for Ry, which is equal to the summation of all the vertical components of all the forces. So for Ry, we already know that that is 300. So that will be 300. Since it is upward, it will be positive, equals to the summation of all the forces or the vertical component of forces. So the first force is force F. So the vertical component of this is F sine theta. And since it is directed upward, so that will be positive. Now, for 500 Newton force, so there will be no vertical component for this since this is a horizontal force. Okay, so let's proceed to 240 Newton. So the vertical component for this will be 240 sine 30 degrees. So since it is directed downward, okay, it will be negative here. So this will now be the second equation. Okay, so from the two equations, okay, we can solve for the value of f and theta. So we can, what we can do here is solve or separate the variable f or the unknown force f. So separate it on this side, and then solving for f, it will be you will just transpose 500 to the opposite side. So that will become positive 500. And then we have here positive 240. So if we transpose that to the opposite side, it will become negative 240 cosine 30 degrees. So since what we need here is f, okay, so let's divide both sides by cosine theta. That's why cosine theta is here. So your f will be equal to 500 minus 240 cosine 30 degrees over cosine theta. Now for your equation 2, generate also the value of f. So your f here will be 300, and then transpose 240 sine 30 degrees to the opposite side. So that will be positive 240 sine 30. Since we all only need f here, so divide both sides by sine theta. That's why there's a sine theta here. So now we already generated two formula or equations for f. We can now equate these two f's. So equating the two equations for f. So this is the first f, 500 minus 240 cosine 30 degrees over cosine theta. You equate that to the f here from the equation 2. So that will be 300 plus 240 sine 30 degrees over sine theta. Now the unknown here will just be sine theta. So we can solve for theta. Okay, so what we can do here is cross multiply. So cross multiplying this, we can interchange sine theta and 500 minus 240 cosine 30 degrees. So we can interchange them. So it will become sine theta over cosine theta is equal to 300 plus 240 sine 30 degrees. And then 500 minus 240 cosine 30 degrees. So from here, we know that the value of sine theta over cosine theta, it is equivalent to tangent theta, right? So rewriting that as tangent theta and solving this 300. So let's input that in your calculator. That will be 300 plus 240 sine 30 degrees over 500 minus 240 times cosine 30. So that will give you 1.43760. So what we need here is theta. So to solve for theta, that is just the arctangent of 1.43760. So input that in your calculator. Arctangent of 1.43760. So that will be 55.18 degrees. So that will now be the theta that we are looking for. So you can box now that. So now to solve for the value of f, you can use this, okay, this equation for f or this f. So we can substitute the theta that we have solved. So in this case, we use the f from your first equation and we substitute theta, the theta that we solved here, we substitute it here. So substituting that, okay, that theta to that equation. So let's input it in your calculator. So that will be 500 minus 240 cosine 30 over cosine of theta, which is 55.18 degrees. All right, so the answer here will be 511.62 Newton. So this will now be the value of F. So these are the answers for this question. F is equal to 511.62 and your theta is 55.18 degrees. So now let's proceed to sample problem number 4. So the block is acted upon by its weight W, which is equal to 200 Newton. A force or a horizontal force Q is equal to 600 Newton. And the pressure P exerted by the inclined plane. The resultant R of these forces is up and parallel to the incline, thereby sliding the block up. So determine P and R. Okay, so the scenario here is that we have here an inclined plane. Okay, so this is the inclined plane, and in this inclined plane, there is a block. So this is the block, okay, and this block, its weight, okay, is 200 Newton, and it is acting this way, okay, upon the block. Now, there's also a horizontal force that pushes the block. Okay, so this is a horizontal force as mentioned in the problem. So this is Q is equal to 600 Newton. And there is a pressure P, okay, which is exerted by the inclined plane. So this is that force P, no? So this force P, this is inclined, okay? So if you are going to put here a line perpendicular to this inclined plane, okay, so there is still a 15 degrees inclination from that, okay. P has 15 inclination from that perpendicular line drawn here, okay. So now these forces will actually meet at a common point. So if you extend their line of actions, they will meet at this common point. Okay, so this is a concurrent force system. Okay, so the resultant here is also mentioned. So the resultant for this concurrent force system, okay, so the resultant is upward and parallel to the incline. So meaning to say, your resultant will be drawn this way. Okay, so it will be parallel to the incline, meaning to say your resultant is also inclined 30 degrees from the horizontal, and it is upward to that incline. So let's solve this. So for our given, we have here the resultant, which is parallel to the incline and upward. Okay. So meaning to say our resultant is 30 degrees from the horizontal, okay, and upward, okay, up to the incline or parallel to the incline. Okay, so our theta x therefore will be 30 degrees, and we are looking, or we are solving for the force P, the unknown force P, and the resultant R. Okay, so let's start solving this by drawing it first, okay, on your X and Y axis. So if you're going to draw your 600 Newton horizontal force, so this will just be horizontal. So this will be your 600 Newton force, okay, if you draw that in this plane. Okay, so that will be 600 Newton, and it is directed to the right. Now, for your W, since this is just vertical, okay, if you draw it here, it will just be vertical here, and that is 200 Newton, and it is directed, of course, downward. Now, for your force P, okay, for your force P, so it has 15-degree inclination from the line perpendicular to this plane, right, to this inclined plane. Now, if we're going to extend this P, okay, if we're going to extend that, okay, if you're going to draw a vertical line here, okay, let's say we draw a vertical line here. So from the vertical line here, we know that this perpendicular line, okay, to the vertical line, the angle for that will be 30 degrees. Right, so it will be 30 degrees. So from the vertical, okay, that will be 30 degrees from the perpendicular line here, plus the 15 degrees, which is the angle of inclination of P from the perpendicular line. So that will be 15 degrees plus 30 degrees. So that will be 45 degrees, okay, in total. Okay, that will be the angle of P from the vertical. So if we're going to draw that force P in this plane, so it will be 45 degrees from the vertical. Okay, so that will be that 45 degrees. Okay, now for solution 1, also it is mentioned that your resultant is upward, okay, and it is parallel to the incline, so therefore it will be 30 degrees, okay, and it will be drawn like this. Okay, so this will be your resultant. So for your solution 1, we can use Rx, okay, and we can sum up all the horizontal components, okay, of all the forces. So don't get confused with resultant R has, so that will be resultant. You cannot include that in your summation for for the component forces or for the horizontal components of forces. So that is resultant, ha? Okay, so now for your Rx, okay, so your Rx will be the horizontal component of your resultant. So your resultant is this, right? So the horizontal component of this resultant is r cosine 30, right? So that will be r cosine 30 degrees equals, so the summation of all the component forces, okay, so the component forces are 600, P, and itong weight na ito, no? So, your 600 force here is already horizontal. So it is directed to the right, so that will just be positive 600. And you have here force P. So this force P, what you're going to get here is the component, horizontal component. So the horizontal component will be this. So if the angle is here, so the horizontal component will be the opposite side of this triangle, right? So it will be P sine. So since opposite, so we're going to use so opposite over hypotenuse. So that will be sine P sine of 45. Since it is directed to the left, it will be negative. That's why it's negative P sine 45 here. Now that will be your equation 1. Now to generate another equation, okay, we can use Ry. So for Ry, that will be summation of all the vertical components of all the forces. So for your Ry, that will be the vertical component of your resultant. So the vertical component of your resultant will be r sine 30 degrees, right? So that will be r sine 30 degrees. And since it is upward, that will be positive, equals the summation of all the vertical components of all the component forces. So the component forces are 600, P, and this W. So for your P, that will be for your vertical component here. Your vertical component will be the adjacent side of this triangle, right? Since the angle is here, so that will be P cosine 45, and since it is directed upward, it will be positive. Now for your 200 Newton force, okay, so since this is already a vertical force, okay, so that is just 200, and since it is directed downward, it will be negative 200. Okay, so your 600 Newton force is horizontal, therefore it will not be included in your vertical in your summation for vertical components. Now this will now become your equation 2. So from your equation 1 and equation 2, we can let's say we separate r, okay, to create an equation. So we solve for r, that will be 600 minus p sine 45 over cosine 30. We just divide both sides by cosine 30, so that what will remain here in this side will just be r. Okay, now for equation 2, solve also for the value of r, okay, in terms of p. So let's just divide both sides by sine 30 degrees. So that will just be r is equal to p cosine 45 minus 200 over sine 30. Now, for the 2r's that we have generated, okay, we can equate them. Okay, so we can equate the 2r. So this will be the first r, 600 minus p sine 45 over cosine 30, equals to the second r, which will be p cosine 45 minus 200 over sine 30. Now, there's only one unknown quantity here, which is p. Okay, so we can now solve p by simplifying this. So simplifying our equation, so this will become, let's just cross multiply, no? So sine 30 will be multiplied by 600 minus p sine 45 degrees, and cosine 30 degrees will be multiplied to p cosine 45 degrees minus 200. Okay, so let's multiply now 600 minus p sine 45 degrees times sine 30 degrees. So distributing sine 30 degrees, so that will be 600 times sine 30. So that will give you 300. So this will be the 300. Now for p sine 45 times p sine 30, that will be sine 45 times sine 30. That will be square root of 2 over 4. Since it's negative here, it will be negative square root of 2 over 4 times p. Now for the other side, it will be p cosine 45 degrees times cosine degrees. So that will be cosine 45 times cosine 30. That will be square root of 6 over 4 p. Okay, so ito yon. Now for negative 200 times cosine 30, that will be negative 173.205. So this will be the answer for that. Now, let's combine like terms. Let's combine the two p's. Okay, so let's transpose this to the other side and transpose this constant to the other side. So it will become 300 plus 173.205, and that will be 473.205. Now, for your p, so let's transpose it to the other side. This will become square root of 6 over 4p plus square root of 2 over 4p. So that will be, input that to your calculator, that will be square root of 6 over 4 plus square root of 2 over 4. So that will be square root of 2 over 2, or 0.70, sorry. Okay, so that will be square root of 6 plus square root of 2 over 4, or 0.96593p. So solving for p, divide both sides by 0.96593. So it will give you p. So your p will be, so divide 473.205 by 0.96593. So that will be 489.90. So this will now be the value of p. So this is in Newton. Don't forget to include the unit for this answer. So box now that answer. Now, since we already solved for the value of p, we can now solve for the value of r by substituting the value of p to any of these two equations. So in this case, we will substitute the value of p to our equation 2. Okay, so we use this. So that will be r is equal to p cosine 45 degrees minus 200 over sine 30, wherein your p is 489.90. So let's input that to your calculator. That will be 489.90 times cosine 45 minus 200 over sine 30. So the answer for this will be 292.82 Newton. So that will be the answer for R. So now that is the answer for this problem. So we can actually solve sample problem number 4 using a different solution. Okay, so we can use solution 2. So for this solution, we're going to rotate, okay, the forces. Okay, so what we're going to do here, so this was the drawing, okay, that we have generated, okay, from the previous solution, from your solution 1. So this is how you draw, okay, this concurrent force system. Now, to make the calculations more simple, okay, and shorter, okay, we can actually rotate, okay, we can rotate the forces in this concurrent force system. So we can rotate our resultant, okay, in such a way that it will be in the x-axis, because if your resultant is in the x-axis, it means that there will be no vertical component for that resultant, right? So if it is rotated here in the x-axis, so the resultant will just be equal to the horizontal component as well. Okay, and again, its vertical component will be 0, so it will be easier. So if we rotate r to be in the x-axis, all of the forces must be rotated in the same rotation and the same angle. So it will be rotated clockwise, okay, through the x-axis, okay, by 30 degrees. So we have to rotate also your 200 Newton force, okay, 30 degrees clockwise. So it will be moved from here, okay, and also your P, it should also be rotated 30 degrees counterclockwise. So it will be 15 degrees here, okay, and also your 600 Newton force here, it will be rotated 30 degrees. So it will become rotated here, okay, with a 30 degrees angle. So this will be the rotation, okay, or the rotated forces. And from here, we can solve this in a much easier solution. Okay, so if r is at the x-axis, your horizontal component for your r will just be equal to r, Okay, and your ry, or your vertical component, will be equal to 0. So this will be our solution. If your ry is equal to 0, okay, equals to the summation of all the vertical component, okay, of all your forces, it will be 0, your ry will be 0, is equal to the first force is p, so that will be p. Since you are looking for the vertical component, so your vertical component, since the angle is here, so your vertical component will be the adjacent of this triangle, right? So it will be ka, so that will be adjacent over hypotenuse, so that will be p cosine of 15 degrees. Since it is directed upward, so it will be positive. Now for your 200 Newton force, okay, so the angle there is 30 degrees, and what you want here is the vertical component, and its vertical component is the adjacent side of the triangle here, since the angle is here. Okay, so what will happen here, we will use cosine, no? So that will be 200 cosine 30, and since it is directed downward, it will be negative, so that's why it's negative here. And for your 600 Newton force, so that will be the vertical component for that is 600 sine 30 degrees. Since it is directed downward, it will be negative here. So we can actually solve directly for the value of p here, right? So solving for p, that will just be we just transpose 200 cosine 30 degrees to the other side, so that will become positive 200 cosine 30 degrees, and your 600 sine 30 degrees will be transposed as well to the other side, so that will become positive 600 sine 30 degrees, and we have to cancel cosine 15 degrees here, so we have to divide both sides by cosine 15 degrees. That's why there will be a cosine 15 degrees here. Okay, so solving for the value of p, okay, let's input this on your calculator. This will be 200 cosine 30 plus 600 sine 30 over cosine of 15 degrees. So this will become 489.90 Newton. So this will now be the value of P. So as you can see here, it's much simpler, okay, because you can directly solve for the value of P. Okay, so now since we have actually your R will now be independent. Okay, no. So we will also use P pala, no? So from your Rx, so you know that your Rx will be equal to the summation of all the horizontal components of your force, and your Rx is actually the R, tama ba? So it is equal to R, so to the resultant itself. So that will be equal to, okay, summation of horizontal components of the forces. So this will be 600. So 600 cosine 30 degrees. So that will be the horizontal component of 600 Newton force. So since it is directed to the right, it will be positive. Now for your P, so that will be what you need here is horizontal component. So the horizontal component here is this side of the triangle. So this is the opposite side of the triangle since the angle is here. So this will be um, P sine 15 degrees. So since it is directed to the left, so that will be negative here. And also, for your 200 Newton force, so the horizontal component for that will be the opposite side of this triangle since the angle is here. So this will be 200 sine 30 degrees. Since it is directed to the left, it will be negative. That's why it's negative here. So solving for the value of R by substituting the value of P that we have solved, so we can solve for R. So inputting this on your calculator, this will be 600 cosine 30 minus the value of P, which is 489.90 times sine 15 minus 200 sine 30 degrees. So this will now be equal to 292.82 Newton. So this will now be the value of R. So these are now the answers for this problem. So it's much simpler than the solution 1. So it's your choice if you're going to use solution 1 or solution 2. So it's up to you. So that concludes this session. I hope you learned. So see to it that you have learned the intended learning outcomes for this topic. And also don't forget to answer the assessment task in the latter part of the course material uploaded. So study well, keep safe, and God bless.